Well, hello. We are going to do the 3.7 Part A notes today, which is graphing absolute value functions. And you can see from the core concept box here, an absolute value function contains the absolute value expression, which is right here that I'm pointing at. And it makes a V-shaped graph, as you can see here, a V shape. And where it changes from a positive slope to a negative slope or vice versa, that little intersection right here is what we call the vertex. And so the parent function, which is what all absolute value functions are based off of, is this exact function right here that starts at the vertex, and it has on the right hand side a slope of positive 1. So you go up 1 over 1, up 1 over 1 to the right, and then you can go up 1, left 1, up 1, left 1 for a negative 1 slope on the left, and that's what we call a parent function. Because the arrows here at the end are pointing that the graph keeps on going forever up and to the right and up and to the left, the domain of an absolute value function is all real numbers, and the range is an inequality. If it's opening up like a cup, the range is y greater than equal to the y value of your vertex. If it opens down like a frown, so maybe like it looks like a mountain, then it would be a y less than equal to whatever the y value of your vertex is. So let's go ahead and get into example 1, which is some graphing. All right, example 1 says graph the parent function of f of x equals the absolute value of x. Then graph each function by making a table of values and compare it to the parent function. So I'm going to graph my parent function here. I'm going to graph mine in black just because it'll be a little helpful here. And the parent function starts at the origin, and then you go up 1 to the right 1, up 1 to the right 1. And we're going to do a slope of 1, and we're going to continue going all the way here to the top. There we go. And then on the left, we're going to do the same thing. It has a negative 1 slope, so up 1 and to the left 1. And this is our parent function. And then we can connect those, put arrows on the end. Now, if I was going to make a table of values here, which I will put one over here, here's x, and then I'm going to do f of x. And later I will do a g of x because we want to graph g of x. Let's just do from -2, -1, 0, 1, and 2. And I'm going to plug in my table of values. So here is my table of values. What I'll tell you right now is this part right here, this is my parent function. Parent function is the first two, and the third column will end up being our new function, which here would be my g of x. So if I go to my graphing calculator and I want to plug in absolute value of x plus 3, let me show you how you would do that. Okay, so I'm going to show you my graphing calculator here. The first thing you do is you go to your y equals, and then you press math. Go over where it says NUM for number, and option 1, which is absolute value. Then you just type in your absolute value of x. Outside of it, you can put your plus 3, and then you can go to your table of values. You can scroll up or down, whatever you need to do to get to the table of values that you are looking for. All right, so now that I have that table of values, let's go ahead and plug in what I got, which is going to be 5, 4, 3, 4, and 5 for the corresponding x values. If I go ahead and graph those, here is the points. I'm going to continue my pattern on the right side, and on the left side, plot the points that I have, continue that slope, that pattern, boom. And if you notice anything that says compare it, you can sort of see it from the table of values. The y values keep going up by 3, but I can look, every single point is 3 points higher than the point underneath it. So I can say that we went up 3. All right, up 3. All right, going over to the next one, I'm going to make a little table of values here as well. You have 3, column 1, x, f of x, m of x. -2, -1, 0, 1, 2, 3, 4. I'm going to go a few more on this one because I know what's going to happen. Let's see, we're going to get 2, 1, 0, 1, 2, 3, 4. And then I'm going to go to my graphing calculator, which is in my hand. I'm going to copy what I have here. I have 4, 3, 2, 1, 0, 1, and 2. The reason why I wanted to go a little further is notice I didn't see any change of direction like where a vertex would be, but notice right here, I see a change of direction, some like symmetry here. So I'm going to go ahead and plot my parent function, plot those ordered pairs. It has a slope of 1. Same thing here. And connect these. Apologize, I don't have a ruler while I'm using my iPad here. And then I'm going to graph the new function. You can go ahead and do the same thing. Plot those ordered pairs. Now, when you plot these, it's almost going to look like you shifted everything up 2. The problem is, look at your vertex. The vertex here was actually shifted over. So the V is to the right 2. Everything's shifted over 2 spots to the 2. So when I write down how would the parent function compare to it, you can say that we went to the right 2 spaces. All right? Okay, let's go to the next page. There are some on your owns here that you can graph and double check them with your graphing calculator, but the comparisons, I want you to, when you graph it with the parent function, notice that on your own number 1, that you go down 1, and that on your own number 2, you went to the left 4. That's what you need to notice. All right, we're going to do the same thing now with example number 2. We're going to graph the parent function. So I'm going to do that right now. 0, 0, 1, 1. I'm going to graph all these ordered pairs. And then the same thing on the left side, ordered pairs. I'm going to write my table of values. I have my x, my f of x, and I'm going to do a q of x. I'm going to do the ones I normally have, -2, -1, 0, 1, and 2, which gives me 2, 1, 0, 1, 2, and the q of x. Put that in my graphing calculator, and I get 42024. So I'm going to go ahead and graph those. 0, 2, 2, 4, 4. Now how to keep going, notice my slope here is I go up 2 and over 1, up 2 and over 1. So I'm going to keep doing that, up 2, right 1, up 2, right 1. Or I can continue doing, look at my table of values and notice that this has to be a line here that goes up by 2 and over 1, and the same thing here. So now you'll notice that the red graph, which is the new graph, is actually skinnier. All right, it's more narrow, and what we're going to do is we're going to call, we'll say it looks more narrow. Looks more narrow. How I can look at that also is its y values are twice as tall. It goes from 1 to 2. 2 to 4, and I can see that over here, 2 to 4, 1 to 2, 0 to 0, 1 to 2, 2 to 4. So I can see it looks more narrow, or you could also write that they're twice as tall. Now if I look over at this next one, let's go ahead and do this parent function, 0, 0, 1, 1. I'm going to graph these fairly quickly. As you do it, you get pretty good at it. I'm just going to put some little dots so I can, since I don't have a ruler here, go through them. So there's my parent function, x, f of x, and then p of x. To make my table of values here, -2, -1, 0, 1, and 2, 2, 1, 0, 1, 2. And then as I put these on here, I'm going to get -1/2 for these, and then -1. So I got my points here from my table of values, which you could put in your calculator. And I'm going to start with 0, 0, and then 1 and -1/2, -1 and -1/2, and then 2, -1, -2, -1. And so you'll notice I'm going to go, my slope is really going down 1 and over 2, if I want to look at it that way. It's down 1 over 2, down 1 over 2, down 1 over 2. And then I can do the same thing, down 1 over 2, the other direction. So this one, what looks different, I mean, it looks sort of the same, but notice it is flipped. This is flipped. We will eventually know it's called reflection. And you'll notice that while it's flipped, instead of a height normally being 2 spaces away from the x-axis, now it's 1. Instead of being 4 spaces away, now it's 2. So it's half as tall. Half as tall. Okay, there are some on your owns here that you can try. If you don't want to, that's fine. And that's the end of the notes for today. We will continue on with 3.7b next time. If you have any questions, please reach out and ask. If not, then we'll just see you next time.